Hello everyone. Welcome to the skills and learning stream. We have an all blue jacket day today. 100% IBM champion talks, and one of the speakers I was most proud to get is Mr. Stephen Perver, who is a very interesting new voice in the space. As you know, with skills and learning, we kind of do focus on kind of the latest ideas and kind of the kind of the issues that people are thinking about at the moment or should be thinking about. And Stephen, who is involved in the community from various points of view, um, running the mainframe of Discord, and a regular kind of speaker, as well as a full-time practitioner within Zono, has lots of interesting things to say about Python on the platform. So I'm going to get out of his way in a second. I would just say usual protocols. We have the feedback, and this is see now I try to think of it. I believe we are 7M.
7N, Nancy.
There we go. Yeah. So we are 7N. I'll say this up front, and we'll probably have a little reminder at the end. Stephen has said he is happy to take questions as he goes along, but he can't see them. I can. So if you put questions in the chat, I can relay them to him. But with that in mind, I shall leave you in his capable hands. Thank you so much, Stephen.
Awesome. Thank you, Herb. I appreciate it. And thank you all for being here. For you, it might not be as early as it is for me. It is currently 4:33 in the morning here in lovely Chicago, where I reside. I got up bright and early just so I could entertain you all and talk about one of my favorite mainframe topics, which is Python. So I'll dive right into this. We got a lot of content to cover. And like Herb had said, please interrupt me as much as you feel like you need to. If you have a comment that you want to say, if you have a question or a correction on anything that I've got going, I'm happy to take those during the session. Just kind of relay those through Herb or however that's preferred for you to do that. Again, this is session 7N, Pragmatic Python for Systems Programmers. This is a bit of a resurrection of a session that I did at Share in Orlando just recently, and it involves a little bit of knowledge about Python, so we'll get into that. So let me really quickly introduce myself. So if you don't know who I am, like Herb had mentioned, my name is Stephen Perva. I used to be, if you just previously had seen me, I was the senior mainframe innovation engineer at Insono. I have now been deigned to be an expert now, which is a fantastic honor that I'm glad to have. I'm the expert mainframe innovation engineer at Insono. I design and architect add-on services for our ZOS line of business, our mainframe line of business specifically. I've been a ZOS systems programmer for about 15 years now, and it's been quite the journey. I grew up with computers, and I am now starting to kind of bridge this gap between traditional ZOS people and what I would consider progressive ZOS people. Outside of my professional life, I've been a hobbyist developer. I like to make video games. I like to make systems administration scripts for computers that I manage. I also like to just kind of create applications, normal old applications like house management stuff. How much toilet paper do I have? Different things like that. I do all kinds of fun, creative projects with the computer. I've been an IBM champion, like Herb had mentioned, since 2022. I am now into I believe it is my third year here in the program, and it's been such a fantastic program. So if you are enthusiastic about mainframes or anything IBM, I highly encourage you all to kind of give that a check. One thing I do want to mention, you might notice from this silly photograph of me and my boss, I am the one on the left there. I am the founder of a little group called 7 Nines, and that sponsors a few different things. The System Z Enthusiast Discord, if you're familiar with what that is one of those really, I think, really cool things. and the other is I do silly merchandise. I do the fun little t-shirts like you see me in the picture there, and then I have a poster behind me if you can see my camera. All kinds of fun stuff about that. So that's me. Enough about who I am, and more onto the topic. Like most speakers like to start with a optimistic agenda. I am not like most speakers, and I love to start with a pessimistic agenda. So what aren't we going to be talking about today is something that I want to do. It's kind of level set with everybody. So the first thing I want to say is that I'm not going to be teaching you how to write your first scripts in Python on ZOS. My intention is that you would know how that works already, and that you will likely be able to read through the examples or screenshot them. I believe there's a recording of this. You can get at that however you feel. Um, the other thing I'm not going to cover is the installation of Python. I'm sure others have covered that up to this point, and you will likely be able to follow the documentation IBM provides for that as well. I'm not going to talk about basic Python syntax because it's a pretty easy to read language. It's pretty easy to manage from that perspective. The other thing is that I'm not going to be discussing kind of the nuances between Python and Rex. Unfortunately, those might creep into the conversation a little bit, but I don't really like to kind of play the this versus that game with the languages like most people tend to do with respect to scripting languages on ZOS. So taking away from that, let's talk about what we are going to talk about. So the first thing we're going to talk about is a little product called ZOAU. Specifically, we're going to talk about it as a Python package and how it relates to Python. And the second thing is just talking about packages in general. You're going to find that packages are kind of the bread and butter of what makes Python a fantastic and exciting language. And that is going to be something that I want to specifically focus in on. We'll talk about some scripting examples. I have a few. I have a lot more interesting ones that I would love to have plugged into the slide, but I'm kind of bound by some of the regulations of the company I work for of things that I can and cannot display. So I will talk about them hopefully at a high level if I recall. Common issues, since I am a pessimistic presenter, I will talk to you about things that you might run into trying to bring Python into your environments. And then finally, we'll talk about what I call operationalizing Python scripts. That's how are we going to shoehorn these fantastic scripts and things that you create into your scheduling package or whatever it is you might use to run the operations of your day-to-day ZOS implementations. So from there, we are going to talk specifically about ZOAU from the perspective of Python. So if you're not familiar with ZOAU, ZOAU is a package called Z Open Automation Utilities. And as a standalone product, it's a free product. You can get optional paid support for it. IBM provides that. As a product, it serves as kind of this bridge between Unix system services and ZOS. So what it does is provides a number of different commands that allow you to issue Unix-like commands to access ZOS resources. That's things like datasets, jobs, operator commands, TSO commands, as well as a number of other different ZOS resources straight from your Unix terminal. There's two specific functionalities that I'd love to talk about in a little bit of depth, and this is the idea of running operator commands as well as running ZOS load modules. And thankfully, the echo of myself has just shut off, so I can put my other earbud in here. So I apologize if I sound a bit disjointed there for a second. So let's talk specifically about these two modules because I find that they are probably the most underrated functions of ZOAU at large. And I think that once you understand how valuable these two bits are, you're going to find the value of ZOAU as a package. So first, let's dive into this idea of operator commands. I had a bit of fun with the AI art generator for this presentation. So if you're tired of AI art, I apologize. This place is littered with it. This is just kind of what you're going to get from me right now because I just wanted some cool art to go along with all of this. The ZOAU operator command module is provided to allow you to issue, as you can imagine, operator commands. You can see a little code snippet here showing you how in the one function provided by this module so far is just the simple execute module. So in order to invoke this, all we're going to do is import the ZOA utility Python module. That's that first line there. And then we're going to issue the opercmd.execute, and passing into it as a string is the operator command that you'd like to issue. So in this bit of code here, I just store the response of that into a variable called resp. So something I kind of want to caution you about, and you're going to see more of this as we go through the presentation, is that when you issue this operator command, there's a return code value of the response of this, and you can see in the reference at the bottom there what that return actually is. But the return code isn't going to check you for sanity. So if I were to plug in there opercmd.execute and my command was just Stephen, I would still get a return code of 0 from that if my system allowed me to issue that operator command. And what that's going to do is basically just throw back to me. It'll say, yes, I got a return code of 0. And as you would expect, the response I'm going to get is simply going to say, Stephen's not a valid operator command, you bozo. What were you trying to accomplish here? The only time you would get a return code of non-zero, I believe, is if you're not eligible to actually issue operator commands. So in that case, you can kind of see where that else clause would fall through, and I would probably get an error message that says something along the lines of your security isn't set up correctly, because there is a SAF profile that goes along with the ability to issue operator commands, or some other problem with how I set up ZOAU that prevented me from issuing that operator command. So why is this important? Why would anyone care about this? So say I ran this bit of code, you're going to see exactly what you would expect to see from SDSF. You're going to get this out to your SSH terminal. If you submitted this in a batch job through BPX batch or something, which we'll talk about later, you'll just get this. You're going to say, well, Stephen, who cares? I can go into SDSF and I can issue an operator command just like the rest of them, and I will see exactly what you're showing me. Why do I need Python for this? The answer is you don't actually need Python for this. But why would you want to do this kind of dovetails into the idea of why you would want to do this any other time at any other place. And for me, it's because as I work for a managed services provider, which I didn't delve into in my intro, which I typically do, we manage hundreds of different LPARs of disparate configurations that may look and behave in entirely different ways. So there are a lot of interesting bits. If you were to be dropped from a desert into a new environment, the first command you're likely going to issue on ZOS is most likely going to be display IPL info. So what I've done is I've taken that opercmd module, taken the power that Python has for processing strings and all of that, and created this display IPL info Python module, which basically takes this output here and will actually serialize it into, in this case, a Python dictionary. I could then swizzle that into a JSON payload, maybe a bit of XML, and maybe if I want to export that off the platform so that I can kind of serialize the different systems that we manage, so that I can maybe load this into my CMDB, which is kind of my configuration management database, which tells me everything I need to know at a glance about every system that we manage. So if someone asks me the question, without having to log on to the system, I can tell them what the IEA sys concatenation is, just because it's been loaded into the CMDB. So hopefully that will demonstrate to you kind of the power that Python brings to the table, especially when paired with very trivial bits of information like display IPL info will provide to you. Another thing you might want to do as systems programmers is you might say, if the system isn't ZOS 2.5 or greater, I don't want to run this script. Or maybe if it's less than 2.5, but it's greater than 2.2, heaven forbid, you might want to behave your script a bit differently. So you can basically ingest the fmid there, that's that third field, and you can behave differently depending on what it says. So that's going to actually save you from kind of some of the troubles that you're going to see by trying to automate complicated tasks by wrapping a lot of that functionality up in Python. So a little bit of enough about ZOAU operator commands, and let's move into what I think is the absolute most underrated function of ZOAU from a Python perspective, and that's the invocation of load modules. So some people would argue that this is the way that you can effectively replace JCL using Python. I personally wouldn't recommend that because when in Rome, do as the Romans do. We're on ZOS. Sometimes JCL is absolutely appropriate to use, but sometimes you want to make more intelligent decisions with your jobs than you would be able to do with JCL. So Python kind of gives you that power through the MVS CMD module from ZOAU. The MVS CMD module comes with two functions. Both of them look near identical, but serve two separate purposes. The first is execute, and the second is execute underscore authorized. Both of them take a program name as their first argument. Program args would be the second argument. That's kind of the parm equals statement, which I'm going to show you an example of here in a second. A list of the DD defs that you'd like to throw at this invocation of this module, and then kind of your keyword arguments and your optional arguments on the tail end of all of that. So as you can see in my code here, the first thing we do again is import that part of the module, which is the MVS CMD part of the ZOA utility module. And then we're just going to simply invoke MVS CMD.execute, pass in the name, and I've given you kind of the classic example, which is running a simple IEF BR14. But in this case, opposite of what Opera CMD issued to us, the RC value stored in this result is actually the condition code that execution of that module got. So if you're used to getting a condition code 0 from IEF BR14, much like you probably should be, this is a bit of a silly example. In this case, it would just simply print the result, which is a special class that ZOAU returns called the ZOA response, I believe it's called. And that will have all of these different variables that you can inspect to see what is going on with that. So let's transcend from the trivial to something a little more fascinating. So invoking IEFBR14, not super exciting, but now that you can kind of take that, we can do more with it. So in this case, we've kind of ramped up in complexity here. We've gotten to invoking a module called HCS print. You can see that. Hopefully you can see my mouse pointer here. I'm kind of swirling it around. If not, it's the sixth from the bottom line, which is an APF authorized program. And in this case, I'm creating on that third line that you see down, that temp name. So I'm creating a temporary data set to store my output. So this is a really cool example because it shows you not only that I can add DD statements to the invocation of a module, but it will also show you how to, say, create a data set and read from that data set and write to it using a module. So in this case, I just do that mvscmd.execute authorize down here, calling HCS print, which is kind of this health check module to get the details of a health check. And in this case, what I do is, if you've seen a parm equals statement in JCL, this is exactly that. So where you would want that parm equals, I pass in this check name here saying I want all the details about this check. And then any DD statements goes here on this DD's line where I just basically pass in a list of DD statements. So say you have like sysout equals star, you could basically do DD statement name equals sysout definition equals, and then I think a static string of just star will be sufficient for that. You can pass in Unix files as DDs to calls like this. You can pass data sets that you've created, data sets that already exist. You may want to pass in sys1 samplib or something like that. And so what do I do once this executes? Well, if it executes successfully, I'm going to then take the datasets module, read all of the output that it just spun out into this data set, and then I'm going to use in this final line here what Python, I believe, calls list comprehension, and print every line that is in that data set. So what does that actually look like? Well, here's a bit of a trimmed down example of what that looks like. If you've ever seen HCS print, this thing goes on and on and on and on. But what this does is basically just print out the detail of a simple health check. So why on earth would you want to do this? Well, I created a dashboard for systems that'll show me all the health checks that are successful, that have failed, that may be in exception status or not applicable. And I basically stood it up in front of a Flask web server that runs on ZOS. And you can click on each one. And behind the scenes, what happens is it'll actually run this health check detail and tell you why the check has failed or why it's successful, teach you everything you need to know from a simple drop down. So as you can see, you can kind of use the power of Python to do all kinds of really fun stuff. So maybe you want to invoke ID cams. Maybe you want to evoke DFH CSD up, which is the module for manipulating a Kix CSD. There's all kinds of really fun things you might want to do. And there's all kinds of times that you might want to add something into that invocation to change the way that it behaves. So let's move on here from this notion of load modules to talking specifically about packages. And if you've used Python before, which I hope you have, you will understand why packages are very important to the ecosystem. And the first reason is because you get a ton of functionality from Python packages without having to create it like you might want to do in other scripting languages on ZOS. A few silly examples, which we're going to get to, is the usage of pandas for data frames, or the usage of, say, the CSV package to parse CSV data that you may have created from SAS and stored in a data set. You might want to connect to a Postgres database from ZOS. You may want to connect to a Snowflake environment from ZOS and pump your ZOS-based data into these environments without having to go through some wacky ETL process that you might be used to today. So you might today FTP that data, transform it on a non-Z platform, and then stuff it into a database. Using Python, you really don't need that platform in the middle to kind of do that. You can get a lot of really cool functionality just out of the box. Packages provide you with a bunch of reusable code that you don't have to create every time. Instead, you can now write a piece of code that works on Linux, may work on Python using Windows, and then you can port that straight over to your ZOS systems and run it, assuming that the packages are what they call S390X compatible. That's the IBM Z architecture. Assuming they're present and assuming they're compatible, those should fire up and work just fine in your ZOS environments as they do everywhere else. One good one is when I'm working with interns at Insono, oftentimes we will see that we can hand them a set of data and say, we'd love to port this data into, say, MongoDB or something like that. And we can say, we'd love to plug this data into our MongoDB database. Can you write a bit of code to serialize this plain text data and then stuff it into MongoDB? And they'll do all that development off the platform, hand me the code. I'll make a few minor tweaks to say, instead of reading a file, read a data set, and we'll just pump that directly into MongoDB without having to do anything. And suddenly these people are very productive without having to know a whole lot about ZOS. And we have an internal challenge at Insono called the CEO challenge. And we've had 2 interns write Python scripts for ZOS and win the CEO challenge 2 years in a row, simply because of how powerful this language is and their ability to derive insights from ZOS data that provide tremendous business value. So a topic that I want to talk about, and I have to talk about, especially with respect to packages, is how can we safely get them? Right now, you might use packages and you might just go pip install and just grab whatever you want. I want to show you that that might be a tiny bit different on ZOS. And especially when we're talking about security, there is a little bit of a difference. So it might be scary to you to jump into, say, the Python documentation that IBM provides and see the section about setting up your compiler, and then you're starting to be horrified about, well, what do I need to know in order to use a language that I perceive as simple? Well, you really don't need to know a lot. There are several languages that there's several compilers that I believe will help you be productive should you want to build packages that aren't popular. You can use the ones on the screen here, the licensable ones. That's that XLC C++ compiler that you may or may not license today in your environment is an option there. but IBM does provide that first one there, which is the C, C++ for open enterprise languages. Again, that's a C, C++ compiler provided for free to people to use to compile code for these open source style purposes. And again, IBM does recommend that you actually use either their free provided compiler or their XLC C++ compiler when working with Python packages that might require compilation. So why would you need compilation if Python is an interpreted language? Well, some packages actually use C modules, C++ modules, other language modules, maybe Go might be in there as well, to provide some performance or just some reusability. So maybe something was created that was already compiled in C and they just want to invoke that. Or maybe you have some C code or C++ code you'd love to invoke from Python. You may require compilation to do that. You get some performance optimization and you get kind of compilation that is native to the S39D architecture. Again, that's that Z architecture. But what I do, now that most of you are already asleep, want to tell you is that I've made it probably 3 years of using Python without ever having to invoke the compiler. The first time I ever needed to invoke the compiler from a package was when I wanted to interact with the Snowflake platform. And I don't believe yet they have a native S390X package for that. So you can see at the bottom there, there's a little reference to help teach you a little bit about what needs to be done to kind of get your Python compiler set up should you find that you need that when you go to get a package. I'm going to take a quick drink and see if anybody has a question, comment, or anything. Okay, so now that we've gone through the scary bit, let's talk about an even scarier bit. This is the idea of security. So when you're talking to anybody about bringing Python into your environment, the first thing people tend to do is say, well, Python isn't secure. You've heard about all of the scary things that happen with open source stuff and widely available languages and packages like we're used to. What I want to show you is that there's actually really, really safe ways of achieving packages and acquiring packages for your ZOS environments. The first things is I want to kind of make you aware of what you should be aware of. The first thing is making sure that you're not getting packages that have been tampered with. So you've probably heard of a number of different attacks out there that have happened recently where popular bits of software have been manipulated by malicious actors. This is the idea of a watering hole attack. So somebody who will take and change something in a very popular, openly available product or package or open source project and make malicious changes to it without alerting anybody is considered a watering hole attack. If you've watched Toy Story, you've heard of Woody saying, "Oh, somebody poisoned the water hole." This is exactly that. So somebody has injected some malicious code into a popular package. Somebody naive like myself will go, "Oh, wow, there's a new version of my package. I'm going to go ahead and update that." Suddenly, I've just downloaded some malicious code. The idea of what's called a supply chain attack is when somebody from a trusted vendor gets and injects malicious code into a trusted vendor's repository. Suddenly you're pulling that into your environment. So we want to make sure we're staying secure through these concepts and we're complying, since these are critical infrastructure ZOS environments, complying with any sort of regulations or compliance things that we are subject to, regardless of wherever we're at. Here's a fun example of a trivial attack. You might be out there typing pip install. You might want to get the requests module and you end up typoing it and you accidentally type requests instead of requests. Next thing you know, you're going to install or download a module that looks and behaves like requests, but has a malicious payload associated with it. And if you're like me, your fingers kind of have a mind of their own. You're going to type in pandas because you want to do some pandas data frame stuff, and you happen to type pandas instead. The next thing you know, you've been affected with a whole different set of problems as opposed to being able to use data frames like you would expect. So how do we protect ourselves from things like this? And this is really for kind of the architect people out there. So there's three major repositories that I want to talk about. And the first one, this building blocks look up there, is probably one that most of you are familiar with, is PyPy. That's PYPI. That's the Python Package Index. And that's the one most people are usually familiar with when you're talking about Python. That's the one where you type in pip, install, insert name of the package. It's going to go out to PyPy and download whatever package it is if it's there. So this is that simple out of that box functionality that people love and enjoy about Python on other platforms. This repository is cool because it stays up to date. Git projects or open source projects can quickly throw their projects out there and you can get them as quickly as you need to, and you can access this from anywhere. If you're using your laptop into a pip install on a package, it's going to be effectively the same result as if you're using ZOS and you use that pip install. You don't have to maintain configuration files to get this, as opposed to some of these alternatives I'm going to discuss with you. And you don't have to maintain a whole lot of the packages themselves. The second option, why I have the IBM logo, is the Python AI Toolkit for ZOS. So the Python AI Toolkit for ZOS provides you with vetted packages. IBM has vouched for their security, has informed you that they believe they're secure, and they are confident in distributing them to you as well. These are purpose-built packages, so if the package is listed on the Python AI Toolkit for ZOS, you can guarantee that it's actually going to work with ZOS. And it comes with, I probably should strike out easy to use. It comes with a web interface. It feels easy to use, but it has some rough edges as well for exploring what packages are available. And I've linked to a red book there at the bottom, and I believe it actually discusses the AI toolkit and how you can implement that as well. So that, I think, is probably your first best option for getting something. The kind of nirvana of package acquisition is this last one, and that R symbol stands for Nexus. This I don't know what the R stands for, but it's a Nexus repository is what they call that. And you might already have these in your environments today. A Nexus repository might be used by your distributed folks to gather packages for other bits of infrastructure. And the nice thing about this is it's an internally managed repository that can serve just your systems and kind of provides you with that sense of what's considered quote unquote offline access. So if your environment says, well, we don't go out to the internet for anything, this might be a viable alternative. You might be able to say, can we post up a Nexus repository that serves as maybe a proxy to the IBM AI toolkit so that we can say we trust just this repository and we trust that it's going to get that for us. It does have support for other technologies, so it might be a viable option if you do Java development. Maybe you do Node.js and you need some NPM packages. Maybe you need some NuGet packages for your C# stuff. There's some container functionality supplied with Nexus repositories that you might want to get off of using that software as well. Plus, it's infrastructure you might not have to manage going forward. So that's why I always tend to advocate for the Nexus repository. It can serve as a cache as well, meaning that every time you go and get a package, it's not going out to, say, PyPy or the AI toolkit and downloading it every single time. Instead, you're going to an internal within your DMZ repository, and it had downloaded that once. And since there's no updates, it's not going to keep downloading that over and over and over again. Instead, it's going to just distribute it to the environment that requested it. So let's talk about kind of the worst scenario that exists. And a lot of you might fall into this bucket, unfortunately. And this is the idea that our ZOS environments have no access to the internet, and all we can do is move things to our ZOS environments using a trusted source. Maybe that's your workstation. Maybe that's some Windows VM or a VDI, they call it, a virtual desktop environment. In this case, it is still possible to get packages. So what you're going to do is go to a system that does have internet access. You're going to make a list of all of your packages, And you can look at the reference at the bottom of this slide to learn how that gets done. And you're going to make a list of packages in what they call a requirements.txt file. And then you're going to issue this pip download command pointing to your requirements file. And what that's going to do is download all of the required packages, as well as any dependencies those packages have, and put them into just a directory that you can transfer then to your ZOS LPAR and install them. This final bullet point here saying you will want to use the platform and Python version switches, as well as the only binary, if you don't want to get any source distributions that you have to compile on your ZOS side. So that reference at the bottom will explain how to do that. For platform, that's just what architecture you're on. That's where you're going to want to say, I want S390X. The Python version, maybe you're on 3.11 and the latest is off the platform might be 3.12 or 3.13. I'm not 100% sure. Make sure you plug in your appropriate version there. So then when you get those files to your system without internet access, you're going to then run that pip install. You're going to say no index because you don't want it to go searching for things on the internet. That find links will tell it where it's going to find everything. And then you're going to point it to that requirements file. So that path where packages live, maybe you put that in /service/packages or something like that. You can just point it to that and then point to your requirements.txt file. I recommend using the AI toolkit or an internal Nexus repository. If you must do this manual thing that I'm talking about, again, I highly recommend that you use those two repositories if you have them, that AI toolkit or the internal Nexus repository, just to make sure that your packages are safe and coming from a trusted source versus just the internet where kind of anything can happen. So in the topic of packages, let's talk specifically about ZOAU. You cannot just do a pip install of ZOAU. Instead, ZOAU, when you install the product, actually comes with what they call wheel files, which are binary distributions of the Python package. So ask whomever installed ZOAU, and if it was you, chances are you have an environment variable called ZOAU_home, which will point to where your ZOAU directory is on your system. You'll just do a quick pip install. You're going to point at the wheel file that's applicable to your version of ZOAU, which is that first version insert there, and then your version of Python. So if you're on 3.11, it'll just say CP311, and then that's the full name of the wheel file. So for example, if I was on ZOAU 1.2.5 and Python 3.11, you see my file name here is pi-1.2.5.0-cp311-none-any-.whl. Once you've done that, you can do this one-liner here to test it. That's that Python-C import ZOAU util pi. If nothing comes back, you've done it well. If you get a module error coming back, or module not found error, I believe it is, coming back, you know that something has gone a bit awry there. Or you can just do a pip list, which should tell you what you've got installed as well, should tell you. So let's talk about some cool scripting opportunities. So we saw this one earlier in the presentation. Probably not so cool now that you've seen some of the other stuff that I've talked about, but it's about to get a little bit cooler. So we have this display IPL info script, which serializes kind of the results of that display IPL info command. And now we're going to create this other one where we're going to do a display parmlib command. And under the hood of that, we're going to serialize that and create another payload. In this case, it looks to be another dictionary that just says, I got these from at IPL time, and these are the entries in the order in which they show up of all of the different parmlib data sets. Okay, so we have our display IPL info script. We have our display parmlib script. So what do we do with what I call these atomic modules? These are these small little modules that do one simple thing. Well, we can use the display IPL info. We can grab that IEA_sys suffix. We can then issue that display parmlib to get the parmlib concatenation. And using both of those modules in concert, we can then read every IEA_sys XX member, build one large IEA_sys XX buffer, and then programmatically, we can rip through that buffer and find all of the all of the different SMF data sets that we might want to locate there. So again, we've created a locate underscore SMF parmxx script, and it's going to do those behaviors for us to say, hey, these are all of the SMF equals data sets that are showing up in IEA across the system. So then we can then take those, find where they're at, and we can serialize those and make intelligent decisions about what that SMF configuration looks like for that system. So let's rewind our brains a little bit to the notion of me managing hundreds of different COS LPARs with different configurations. If we want to unify them under a singular SMF configuration, making sure, hey, are we collecting 110s for this system? We could use effectively this different set of scripts to make that intelligent decision for ourselves. So I'm going through my notes here to see where I'm at. Another one that's really cool, this one might make a lot of you wonder why you pay for certain products, is this idea of serializing the syslog. We can invoke this syslog serializer. Again, this is a bit of code that I wish I could share with the world, but I unfortunately cannot. But what this will do is it'll actually take a snapshot of the syslog. Maybe we run it every 5 minutes. Maybe we run it once a day. It's going to serialize it into a bunch of JSON, and we can take that JSON and we can send it to a syslog aggregator. That could be something like Splunk. That could be something like Apache Spark or something that just aggregate all of this information and put it together in a way that we can then search it in an intelligent way. So this is really kind of showing you just the tip of the iceberg of what you can do. I think this might be one of my last examples here is kind of a meta example. This is me installing ZOAU using Python. So the first thing I do is I go and I download the Python PAX file from IBM using curl. And then all I do is I invoke my install script pointing at that PAX file, giving it the name of the data set that I want to install that into, or a ZFS that I'd love to create for that. And what this is going to do is kind of spin through that archive. It's going to install it for me and then replace the existing installation with something that is functional for me. So in this case, I have been able to take a ZOAU installation process that might take me, say, 30 minutes to an hour, and I can transition that into something that takes me potentially 25 to 30 seconds. So this is a good way to kind of demonstrate that Python can help you with any of your automated complex tasks that might be a little bit, that might need some decision making. So in this case, it needs to swap some ZFSs under the hood, and then it might need to install some packages as well. Those are those wheel files I was just talking about. And that should set you up for success. The sky is the limit with these types of activities that you can do on your system. So while this is all great and well, very inspirational, back to the idea of the pessimism that kind of resides within, I do want to talk about some issues that you might have with adopting these types of technology. One of the first things that most of you might realize is this idea of kind of cultural issues. We see it across the mainframe industry all the time. And this is the idea that we have a set of rec scripts that do this, or we have a set of C lists that do this. Why would we want this Python technology? Why would we want to take a chance on a bit of technology that advances at such a rapid pace when we have old reliable kind of there, kind of chugging along, doing just fine? That is probably one of the biggest issues that you're going to run into, is kind of this idea that your scripts were not something that were kind of born at the dawn of time with the other things that exist in your implementation. Those are things that I've just had to work through by just kind of advocating for these new technologies and trying to kind of encourage other people to use them. There's a perception of incompatibility. People, for some reason, believe that Python just doesn't simply work on ZOS. Obviously, that's not true. In the last few years, we've seen a ton of adoption and usage of Python across the kind of different environments in the ZOS ecosystem. Just because you use Python, it isn't going to magically solve connectivity issues for you. You're still going to need to understand, in the case of, say, that script where I was serializing the syslog and sending it to Splunk, for example, you still have to know how TCP/IP works and if I can resolve a host name to an IP address, or if I just need to use the IP address. So be cognizant that you're going to have more ambidextrous skill sets than simply knowing Python and just ZOS. You're going to need to know how to engage with your firewall and security team. So if you're connecting to a web server using requests, you're going to need to tell your firewall team, hey, the ZOS LPAR is going to be talking to this host on our network over this secure HTTP port, and this is how I need you to allow this to work for me. And those types of issues don't just magically get solved using Python. Instead, it's going to kind of just make you a more what I call a holistic technologist, and having to learn a little bit outside of your ZOS comfort zone. Encoding issues are pretty prevalent for ZOS. Because you're going to likely be working with people who want to troubleshoot your scripts and troubleshoot your code using, say, ISPF editor, what I would highly recommend that you do is that you tag your files in Unix system services with the EBCDIC code page applicable to your specific language. In my case, that's code page 1047. So when I create temporary files, or when I write files to, say, a CSV file in Unix, I want to make sure I'm flipping that encoding equals CP 1047 switch when I do the read and write, so that when someone goes to troubleshoot my scripts, they're going to see that code page in ISPF editor. I'm sorry, they're going to be able to see all that text in ISPF editor, read it, and not just see a jumbled bunch of symbols and then call me and say, hey, Steven, I need you to fix that. That Python thing is kind of what they tend to use. The final one I want to talk about is this idea of technical debt pay down. And when you're going to adopt these things, most people will find that you've neglected your Unix system services side of the system for so long. Very few things in the Unix world tend to work for you. Unfortunately, the days of having a 1 MB / temp directory are long gone. You might need to boost that up a little bit to something a little larger, and you're going to be paying that down. One thing I will caution you is that when you're doing this pay down, a lot of people like to raise their hands and say, well, that's why this new stuff doesn't work. It's really not. It's really just you're paying taxes on the fact that you've neglected Unix for quite some time, and you're going to need to do a little bit of work up front to make sure that you're current versus whatever your environment looked like the last time you had to do something in Unix. So kind of be cognizant of those trapdoors that lay in front of you, and kind of plan for those in advance. So let's talk about something a little more positive, and that's this idea of operationalizing scripts. We've written all these fantastic, fun, and exciting scripts, and you're like, Steve, well, why the heck am I going to have to log on to the system and issue this Python command just to run my script? Well, you don't have to do that thanks to BPX batch. Here's two examples of how you can invoke BPX batch. One is this one-liner, which most of you might be used to. But if you need to do something that has a number of arguments, I highly recommend that you use that bottom line, and that's the multi-line one. For that std parm dd there at the bottom, every argument that follows, I would highly recommend that you put it on its own line, because it's going to be a lot easier for you to read and for people to understand what is going on. A big caveat here is make sure your JCL is not numbered. So that's when you're in ISPF, you do the unnum, UNNUM, and what that will do is take those numbers off the far right of your JCL away, because otherwise the system is actually going to treat them as if they're arguments to your std parm there, and you're going to wonder, why is it sending 008000 to my script when I didn't ever ask it to? So this will allow you to create JCL that wraps up these scripts, and it will allow you to plug those into your scheduler. So let's talk about some bigger picture things as we're running out of time here. So what does this all mean? Well, it means that we're creating a simpler ZOS environment. We're making complex things into simpler, maybe one-liner style scripts or intelligent scripts that help people from shooting themselves in the foot or help people to understand the system and be more productive quickly for your environment. So suddenly people aren't going to say, well, the ZOS thing is too unruly. We simply cannot do this. The second thing it does well for all of us in the industry is it creates technologists out of us and not just mainframers. I've decided to stop being in the business of creating mainframers, despite the fact that I myself am a very avid and passionate mainframer. What I want to do is focus on bringing mainframe technology back to its roots. And this is this notion that technology was just mainframes at the time. And now technology is a little bit bigger than that. Now we have to know about other systems. We have to integrate with other systems and we have to interact with them. And thanks to Python, that can be a little bit simpler using different technologies like requests, pandas, CSV, Postgres, MongoDB, Snowflake. Suddenly, we can interact with systems and integrate with systems outside of the ZOS ecosystem, and people don't have to say, why can't you just use this? Well, you can say, well, we can. Let me kind of get that sorted for you. And this is all that vision that we all keep talking about, which is the achievement of this hybrid cloud vision that we've been parroting on about with ZOS and mainframes in specific. So instead of talking about being the hybrid cloud, instead we get to be and actually do hybrid cloud things working with other platforms as well. So this is kind of, hopefully I wanted to leave a few moments for questions. So I'm going to give a pause and have a drink because I'm losing my voice here. So any questions, comments? I'm going to click on the chat thing and see if I see anything particularly interesting here. I
Hi,
see if,
Steve.
go
I
ahead.
was going to say I could read those to you. You can have a little sip. If anybody has any additional questions or one or two I kind of held back that we can maybe go back to. While I'm just scanning those, yeah, I think in the skills and learning stream, this notion of convergence of as technologists as opposed to kind of one-trick ponies, I think is a very interesting theme that I think we like to continue. So Mark was asking which of those compilers are provided as part of the ZOS install base, and where could people get the other ones from?
Okay. So great question, Mark, and thank you for that. And I don't believe any compilers really come with ZOS base. It really is going to depend on your installation if they ordered one with ZOS in that case. But what I would recommend is if you cannot compile anything, there's a reference on that slide there that's going to tell you how to test your own compiler. I believe in the doc will tell you how to test if you have a compiler present. But what you can do if you do not have one is get that Open Enterprise C++ or C++ compiler. Just look in the reference that I provided on that slide, and that should point you to how you can download that one. I'm not a C, C++ expert. I used to be, but especially not on ZOS. But I was able to effectively install and use the open compiler. So it kind of speaks to how simple that one likely will be for you. Again, that's the one I definitely recommend because otherwise I think you have to turn the feature on in IFA PRDXX, which I believe becomes a chargeable feature. So, okay.
Righty-ho. Can Python on Z be called from other languages such as C and assembler? So yeah, we know we can call C and assembler from Python, but can Python be called from other languages?
Another
And I was
fantastic question, Tony. I appreciate that. I do not know if they can. I suspect that they can. I know that assembler specifically has the ability to invoke Unix processes. I suspect this would be like that. Because it's interpreted code, I think you will need to invoke the interpreter. So it might not be as elegant as you're hoping that you can get from that. I suspect that the other way around is most likely going to be the one that you're most interested in versus, using a compiled language to call Python from.
So we have another one. What's the memory CPU footprint of a Python script compared to similar recs?
That's a good question as well. So a neat feature about Python, assuming you grab Python 3.11 or up, is that it is zip eligible. So the Python aspects of the programs that you write in Python will be zip eligible workloads. So if you have a zip processor, you're going to get some um, pretty performant Python code as well as cheaper for your consumption based pricing if that's what you're under. For the memory footprint, it really ultimately is going to depend. I don't know pound for pound what that looks like compared to say Rex. I suspect that when you start to pull in a number of packages, obviously there's going to be a cost of memory to you from that perspective. So hopefully that kind of helps answer that question for you.
Do you know anything about, this is part of the same thread, where the packages get installed? So when you pip install on a non internet connected system, where do the packages go to? Is it
Okay.
the yeah.
Yeah, so there's a directory in Python. So you actually have a few options here. If you're a Pythonista, I believe that's the phrase that they use for people that love Python. You're going to find that you might create a virtual environment, which is a containerized, I'm sorry, not containerized, a compartmentalized copy of Python. And you can flip to that, what they call a venv. You can flip to that virtual environment. You do a pip install, it'll install it into that virtual environment. But if you're trying to make packages available to everyone, a good way to do that is to remount your Python file system, read write, install the package, and it will actually install that into that PyHome that you're referencing. There's a lib directory in there that kind of stores all of that. All your packages kind of fall under that lib directory, and it will be available to pretty much everybody. But should you not be able to mount that read write and it's stuck at read only for you, it'll actually install that into your home directory in a hidden directory that will be packages that just you have installed. So that's one way to do that. I think you can actually point an environment variable at where you want your Python packages to be. I don't know what the environment variable is off the top of my head, but you have a handful of options. It's very I guess ambidextrous with regards to how you're going to point out where your packages are and where they're going to end up. But I think the crux of it is if it's read only, by default, I believe it installs it into your home directory. If it's read write, it'll install it into your PyHome, like you mentioned. If you're in a virtual environment of Python, it'll install it into that virtual environment for you.
Fantastic. And I think we have time for just one more. For an HTTPS connection from a Python script to Splunk, for example, do you need lots of setups, so certifications, key rings, imports? Um,
So,
any
so
questions?
this is once again another fantastic question from Mark, and it's a really prevalent question that I want to make sure we have answered. Is yeah, you're going to have to is it lots of setup? I don't think it's much more setup than you would expect from any other platform. It's likely just going to be, making sure you have a certificate present in a directory that your script can access, or the user invoking the script that you have set up to invoke that script can access. Keyring support is kind of hit or miss. I don't really know the best way to access keyrings, and I just use kind of certificates as Unix files in that regard. So I would love to see more of that, and that might be something that we could kind of push for is having more keyring support in Python natively, because Python does come with a Z, I don't know what they call it, but it's a ZOS underscore util package, comes packaged with the IBM Open Enterprise Python product. And that ZOS util provides ZOS specific functionality. And what would be fantastic is if that utility actually provided keyring functionality for us, so that we could use that instead of certificates when a certificate becomes prevalent. But what you're likely going to experience, Mark, is that you're going to be pointing at a certificate file. So that's likely going to be a challenge that you'll have to stare down with respect to whatever you're putting together.
Thank you so much, Steve. We are at time. Did you quickly want to say something about the graphics that you have there? While I say to people, go to that feedback form. Tell the world about how good this presentation was. Steve, could you tell us what those links you had there?
Yes, sir.
Yeah.
So what I'd like to do is invite you all to join the System Z Enthusiast Discord. And I'll apologize up front for the 3 QR codes. Just kind of point your phone at your screen and hold your hand over the ones that you don't want to scan there. The System Z Enthusiast Discord is a really cool place where a lot of really fantastic people hang out and talk about mainframe topics, Python, using Git with ZOS, and just kind of open source ZOS projects. I would recommend that if you're interested in ZOS or mainframes at all, please join us there and interact with us in real time. It's a fun place to be. We run live events. We do all kinds of really fantastic stuff. The second one is the bundling of Python with base ZOS so that people don't have to go out and fetch it. I'd recommend that you find this idea and upvote it so that IBM kind of knows that we want Python to become part of ZOS. And then finally, please, if you haven't connected with me yet on LinkedIn, I'd love to continue this conversation on LinkedIn and be connected to you and learn about all the fun and exciting things that you're doing in the mainframe space. I'd like to elevate that as much as I can for you. I do want to say, like Herb had mentioned, please fill out evals. Let me know what I did well, what I didn't do so well. And let me know if there's anything that I can do better to be a better presenter to keep you entertained and engaged as time goes on. And most importantly, thank you for listening to me on this lovely 5:30 Chicago morning. And I am absolutely ecstatic for the opportunity to talk to you all today. So thank you so much.
Steve, thanks so much. You've got a long day ahead of you. Hope you get a little nap in the middle. Thanks again, everyone, for joining us, and enjoy the rest of the conference.
Excellent. Thank y'all.